And let's
2 years ago, Cursor 1.0 was released as a VS Code fork that helped you autocomplete your code with AI, like an airline copilot. Then 6 months ago, the Cursor 2.0 was released, with an upgraded chat view that could take control of your terminal to build entire features, like an airline captain. But then, just a few days ago, Cursor released version 3.0, and this version doesn't even want you writing code anymore. Instead, it wants you to be more like an air traffic controller running swarms of AI agents across multiple repos, machines, and even the cloud at the same time. On top of that, Cursor just released their new Composer 2 model, which was allegedly trained in-house and is more intelligent than Claude Opus 4.6, that is if we are to trust these Trust Me Bro benchmarks. But what's even more crazy is that Cursor is not even a VS Code fork anymore and has been completely rewritten from scratch with Rust. That's great news for your RAM, but not everybody is vibing with the new direction of Cursor. And in today's video, we'll break down its controversial new features. It is April 6, 2026, and you're watching the Code Report. Before we can talk about Cursor 3, we first need to talk about Composer 2, which is Cursor's new in-house coding model. When it first came out about 2 weeks ago, it blew our minds because its numbers on the Trust Me Bro benchmarks were off the charts. Intelligence exceeding Opus at a fraction of the cost and at a much faster speed. Better in every way, which is crazy for a new frontier model. But just as NASA tricks globetards that were going to the moon again, Cursor was a little bit tricky about how they portrayed this model to the vibetards. What they initially failed to tell us is that Composer 2 is in fact based on Moonshot's Kimi K2 model, and we only realized that after someone found its model ID in Composer's metadata and posted it on Twitter. That's kind of funny because Kimi itself has been accused of training on Claude's outputs because it will occasionally say, "Hi, I'm Claude." Cursor later apologized for not being transparent, and even though it is just Kimi with some really good reinforcement learning, they released a full technical report on how they did it. But none of this drama really matters, because a model that's smart, fast, and cheap is going to be extremely valuable in the zero-code future of programming. But to optimize the shift from code to agents, they completely rewrote the new interface in Rust and TypeScript. To be clear, the old antique VS Code editor is still there, but this new interface is more about managing agents, so you can almost entirely ignore your code base.
Because coding agents are getting so good. It's a home for your agents, and it combines the power of a professional development environment, language servers, files, remote SSH, with all of the models, and the ability to run as many agents as you want, anywhere.
Many have criticized this as being too similar to OpenAI Codex, but now let's find out how it works in a real-world project. After I introduced Horse Tinder a few weeks ago, venture capitalists have been stampeding to fund it, but now I need an actual prototype. Coding it by hand would take months, vibe coding it would take weeks, but with a swarm of agents, I can bang it out by the end of this video. I'm starting with a fresh project, and the first thing I might want to do is enter plan mode to have it work out a basic architecture. While it's doing that though, I can do other stuff in the background, like maybe I want to have it start working on a separate landing page for marketing, or maybe I want to SSH into a cloud server and have it do remote work on my server, or maybe I just want to switch to an entirely different project and spin up an agent there. Well, I can do that all seamlessly and work with multiple agents in parallel directly from this window. We can monitor the status of each agent, and when we get a yellow dot, it means we need some extra human input, typically to grant permission to run some unsafe commands on your system. But if the dot turns blue, it means that the work is completed and it's ready for review. After a few minutes, we already have 13,000 lines of code to work with. If we go to the right side here, we can then check out the Git history, we can open up a terminal, and we can even inspect the code in this minimal file explorer. But I think one of the coolest features is its built-in browser. Here, we can navigate directly to the app and play with the final product. As you can see here, it includes a perfectly rendered SVG graphic of a Clydesdale, but overall, the design is horseshit. Luckily, we can just go into design mode and start asking for changes. Like, I can't see the text on these green buttons, and instead of trying to fix the CSS manually, I just highlight the element and tell AI to fix it, and it gets the work done in the background. I don't even need to wait for the end result. I can just keep queuing up other fixes, and then after a few minutes of that, I built a billion-dollar social media company that will make the world a better place. But a company that's actually making the world a better place for developers is Blacksmith, the sponsor of today's video. It's a drop-in replacement for GitHub runners that lets you run your GitHub actions twice as fast while costing 75% less. That might sound too good to be true, but they're able to achieve this blazing speed by running your actions on bare metal gaming CPUs with the highest single core performance. Blacksmith also makes your GitHub actions fully observable, so you can quickly track down what's happening in your CI pipeline when something goes wrong, which is critical when you have agents writing thousands of lines of code with no parental supervision. Try Blacksmith for free today at the link below, and you'll get 3,000 free minutes per month when you sign up. This has been the Code Report. sort. Thanks for watching, and I will see you in the next one.
You're good, Charlie. Okay, welcome back, everyone. Now let's get started. Okay, we're working on the grid world. So we already have done our grid world class, our Q learning agent class, and our training agent uh, training loop. Yep, that's done. So all we need to do is, so we have our plot value function, plot policy, play greedy, animate greedy, and all we need to do now is the main function. Yeah. Now, if you guys remember, play greedy and animate greedy. So animate greedy is really just animating whatever is done in play greedy. Play greedy is basically playing through a greedy search, which means taking the closest node or path. In this case, it would be just the action that costs the least. Next is plot value function. So we're going through this training agent, which trains this Q learning agent through this grid. And after that, we'll have this value function, which are Q values, representing all the nodes or sections of this grid. And all we do here is plotting it for the user. So now let's get started with this one, where we just want to, actually, let's just do it right now. Okay. We're just calling all these functions one by one. Let me share the GitHub. So that's the GitHub. I'll show you guys the live share. So up to you guys on what you want to click. And let's get started with Adam. Adam, if you can share your screen. Oh, we only need one person, but yeah, Adam, if you can share your screen and open up grid world underscore template. Yeah,
Yay.
sounds good, James. Sounds good, James. Yep, that one. And yeah, let's get started. So you're gonna wanna Two agents. Okay, let's just do trained equals train agent. Tab. Yeah. Train equals train underscore agent. And we're gonna pass in three arguments. So first one, num underscore episodes equals 500. So you guys, when you guys test this out, you guys can increase it or decrease it however you guys want. Comma max underscore steps equals 50. Same thing here. You guys can change it. Render underscore every equals 0. So this one, we're setting it so that how frequently we want to graph this value function. So let's say you do like render every one, then every step of doing it is going to show you a Q value plot. But yeah, next line, you're going to do plot underscore value underscore function. So we're plotting it. And we're passing in two arguments, trained or train, comma, title equals a string. And the string is going to be, so if you want to do like function string, then you can do str and then function, or you can just do quotation mark, circle bracket. Yeah, that also works, or you can do like quotation mark, how you guys usually do strings. For this one, do final learned value function or something. Spaces. Actually, never mind. I don't think this works because I think you need it to be a, no, okay. Uh, I think that's only for integer conversion. Yeah, that should be it. Okay, next slide. And then we can do env for environment equals Gridworld class, which is capital G and capital W. So whenever we do a class, the first letter is always capitalized just for convention. And for a class, it's like a function. In Python, you're going to want the circle bracket. Next line, for grid world, we don't pass in any arguments. No, you want the circle. Yeah. Uh, let's print. I don't need you to write the print. We're going to do play underscore greedy. And we're passing in four arguments. Train, comma, env, comma, max underscore steps equals 30. Again, you can change the number, comma, delay equals 0.4. Yeah, or 1. Yeah, that's also good. And you can stop sharing. Uh, s- okay, well, let me share my screen. So we're basically done the grid world. Let me show you the final product. I just let it wait so that it automatically finds this virtual environment. And now we can run function. Oh wait, you guys can't see it. Let me share my full screen. Okay, run it again. So this should be the final product. So this is the value function. So we're basically, okay, you guys can't see it right now, but you guys remember how we set like this? I mean, we didn't set it, but we have a start, we have a goal, and then we have the holes. So we're starting at 0, 0, which is here, 0, 0. And we see that we're on this green square. So these values next to it, 0.87, 0.88, 0.90. So these are the Q values. So whenever we do like AI agent training or reinforced learning, we're imagine it like we're building this Q value plot of all the actions that we can take. And we're after we're done training it, we'll have this result of these values, which are like 0.88, negative zero point 0.1 or something. Essentially, we're starting at 0, 0, and we're saying, okay, what's the next highest value, Q value? And then we're just greedy searching it, which is take the largest, the best Q value that you can get. So you get like 0.90, you go here, and then you search for the next one. Like you wouldn't pick the 0 because that would be the whole, right? Which is 1, 2, or what is it? 2, 1? Okay, 1, 2. I guess it does Y value first. Anyways, then it would do 0.90. Next is 0. Actually, I think it does. Right. The only actions you can take is up, down, left, and right. So you go down, right, down, right, down, down, right, right? So then when I exit out of this, we're gonna have the command line prompt showing us how the greedy search does it. So how I explained it right now, right? Going down, right, down, right. Now see, so we see the agent is in A, H are the holes, G is the goal, S is the start, but the agent is at the start right now. So it goes down, then right, down, right, down, down, right. Right? That makes sense? So it's basically searching through, okay, what's the shortest path that I can take to end up at the goal state? But yeah, this is basically what happens for what we previously did. Like, what did we do? Um, like Connect 4. Actually, I don't. But yeah, our next project as well will be using Q values. And I guess I'll explain the next project as well. Let me share you guys the GitHub link. Actually, let me push the code that we made today. Project 9. And then also post the solutions in the solution folder. So you guys will be able to see the solutions for Project 9 on GitHub. And now for Project 10, here's the starting template on GitHub for those who copy and paste or download the files. Now let me show you the next project. Okay. Okay, we're gonna have this is a relatively bigger project. So what we're basically trying to do is, do you guys know what the Pong game is? Kind of like ping pong, but you guys know the first game that was ever made, the Pong game? No? But yeah, the first game ever made was something called the Pong game. Yeah, yeah, you can go to the restroom. You don't need to ask about, yeah, no worries. But yeah, basically it's gonna be two paddles, one on the left and one on the right, and you're basically just bouncing a ball back and forth. So AI Brain is basically the Q learning agent. We've made this a lot, right? So we're basically making these agents that have Q values. And then we have the main.py, basically creating the game environment and the AI agent. So basically creating an instance of the Q learning agent. So, and then we have the Pong game and the play.ai.py. Pong game is basically the class for the game itself. Play.ai is basically the you against the AI. Now, if I show it to you right now, so you guys will make this, where it's basically training. I'm pretty sure OXO games. Maybe you're right. Let's see. Oh, video game. Tennis for two. Okay. Maybe it was tennis for two. But yeah, one of the first. But yeah, basically you're gonna train this Pong or this killer agent to how to play Pong. And you guys can see how long it takes. Basically, we're doing like 750 episodes right now. And you can see the best streak is 17 currently. So, and then the memory size, so how many games you're remembering. I'm pretty sure this is in just bytes or something. But yeah, exploration. So this is, there's something called the Q value function or um, exploration function or something like that. But it's basically how many, at what percentage are you going to try new moves? Because if you only do the same moves every single time, then you're only training on the same moves. So if we as a player shoot it all the way up to the top, then the AI can get it if it only trains on getting everything on the bottom, right? So yeah, let's just stop that there. You guys can see as the episodes increase, the best streak increases, starting from 6 to 20. And oh, I think it's training on the training that I already did previously. So the memory is still big. And then main.py, I mean, play versus AI, it'll be me versus the AI. How do I move it? WS, okay. So yeah, basically doing me versus the AI. And then Pong game, play it. Oh, I believe it's the same thing. Oh, that's just the class. Okay, that makes sense. And then AI brain is also just the class. And this one is the trained model that we're going to save onto our local computer. Make sense to everyone? Then we can start our project. And we'll start with Q-Learning Agent. Okay. So, Albert, can you share your screen? And we'll get started with the AI brain.py. And next will be Charlie. I don't know if Charlie's back, but yeah, Charlie will be next. So just get ready. And yeah, let me. Yeah, let's start with the init function. So we're going to initialize an empty dictionary to act as the AI memory. So this is that memory thing that you saw. So it's just going to be self.qtable equals. Is that a curly? Yeah. Okay, so that's the dictionary. We're setting an internal or yeah, internal variable. Yeah, let's do get Q value. So if the state is not in the self.q table, then we're exploring a new instance, right? So we're gonna save it. So we're gonna save the state, and I'm pretty sure that's Q table, the Q value and where it is, like the pedal location. And then choose action. As you can see, we're going to generate a random number to decide between exploring and exploiting. So this is what I'm talking about when I say the epsilon or the when you guys saw on the as the ping pong was playing, the exploration, the epsilon. So it's basically at what percentage are you going to try out new actions? So if the random number is less than epsilon, then pick a random move. Otherwise, look at the memory and pick the move with the highest value. So you're doing if this random number is less than epsilon, then we're gonna make a random choice. And yeah, or else we're gonna just do argmax on the existing Q values. And yeah, you can stop sharing. And Charlie, whenever you're ready. And mm, next will be Nicholas. So you're going to want to go down to learn. Yep. So basically, we're going to look up the current Q values We're gonna look up for the memory. So how many times we were in that state. And we're gonna define the learning rate and the discount factor. So as the comments say, learning rate is how much we want to trust this new info. I have to restart after this. Your computer? Okay. Okay. Where was I? Yeah, and discount factor is basically how much we want to care about future rewards. And we want to basically find the best possible value that we could get on the next date. And then using the Q learning formula, you just want to update the value of the action. So this is just typical stuff, right? We've done this like multiple times. It'll be repetitive. So I'll do Q underscore values equals self dot get underscore Q values state. And this is basically passed into our function. So yeah, just state. Next line, we're going to do the same thing, but the next Q value. So do next Q values equals self dot get Q values, and we're passing in the next state. Next underscore state. Alpha equals 0.2. Gamma equals 0.9. So alpha is going to be learning rate, and gamma is going to be discount factor. Best underscore future underscore Q. Best underscore future underscore Q. Is there a reason that you do capital the first letters? Are you used to like JavaScript? Okay. Q value is equal, but no, no, you don't need to change. But it's equals max function, max function, and we're passing in the next underscore Q underscore values. Yep. Next line. Now we're gonna do the Q learning formula, so it's just gonna be Q underscore values, and we're accessing the action index. So do square bracket action plus equals outside. Outside the, yeah, plus equals alpha times circle bracket, and we're gonna do reward plus gamma times best underscore feature underscore Q minus Q values, and we're accessing the action index. Yeah, action. Yep, that's good. And you can exit or stop sharing and then restart your computer. Nicholas, can you share your screen? And we'll do save model and load model. And after Nicholas, it'll be Adam. So just get ready. Nicholas, are you able to share your screen? Okay, probably not. Then Liam or Jordan, are you guys able to share a screen or? So these two functions will be easy, save model and load model. So save model, you're just gonna do with open, space, open, and this function. So circle bracket, file name, comma, actually, um, string. So quotation mark, WB. And then to the right again, delete, delete, and then outside of the circle bracket as F. Oh, Charlie's back. As F, and then colon. Uh, dot dot like it should be right to the left of enter. Oh, hover on it. So you see the expected colon. That's what we want, the on the second line. Yeah, exactly. And the next line you're gonna do pickle dot dump, dump, dump. Yep. And that's a function, and we're gonna do self dot q underscore table. Yeah. Comma F. Next line and backspace outside of the with, print, and it's a F string, so I'll do F. F is gonna be outside of the string. So this is called a F string. So basically what it allows you to do is you can write variables inside of the string using a curly bracket. So how you do it is, so first do model save to, and that's just string. No, inside the string. So the same thing, F string, model save to. You don't need the underscore. This is just going to be plain text. Yep. Save to TO. TO. No, yeah. And then do inside the string, you're going to do curly bracket. Yeah, space curly bracket. Not the circle one, the curly. Curly should be, yeah. And then this allows you to put a variable in it. The variable you're going to want is file name. So yeah, quickly going over. So for people that don't know how to open a file, or yeah, open a file, make a file, you do in Python, you want to do with open. Open function basically opens the file. With makes it so that you can do it as like create an alias to it that you can use. Alias means nickname, or maybe that's easier for you guys to understand. So you're basically doing with open this file name, which is passed into that save model function, and you're doing it, you're opening it with permissions are which are WB. W means write, B means I don't know something, I don't remember, and then you're opening it and you're referring to this file as F. Now that F variable you can change the name to like file something else, but usually it's F. And we're using the pickle library. And pickle library, there's a function called dump. We're basically just dumping this Q table into that function. I mean, file F. Dump function, you guys will see it a lot with JSON as well. So if you're using like JSON files, which you guys use a lot with Python, Python is usually used for what do you call it? Scripting, as well as I forget. But yeah, looking through and searching through log files as well. So yeah, basically just doing dump is basically putting in your dictionaries or strings into the file F. The opposite of dump would be load. So it would be pickle.load F equals self.qtable. So that would be the opposite way, where you're setting the self.qtable to whatever qtable is in the file F. And yeah, F string is basically you can use a variable inside of the string. So when you guys print it, it'll be like model save 2, and it will show the whole Q value list. I mean, dictionary. Uh, let's quickly do load model as well. It won't be that hard. 10. Yeah. Uh, so now we'll do something called a try and accept. So try and accept basically allows you guys to do try colon, which is yeah, and then enter, then do like the previous function, you're gonna do with open file name function, file name, comma, but it's gonna be RB, string RB. So R means read, B, I forget, as F, as F. No, RB, and then outside of the circle as F, colon, enter, tab, yeah. Self.qtable equals, oh, it says there, pickle.load. Yeah, self.qtable equals pickle.load. My bad. I like configured pickle.load and function F. And before that pickle, just do self.qtable equals. But yeah, now we're doing the opposite, right? First, we did pickle.dump. We're dumping the qtable into the file F. Now we're loading the qtable from the file F and inserting into self.qtable. Enter, next line, backspace. We're going to do print function f string model loaded from curly bracket file name. Yep. Next line, backspace. Now, whenever you guys do try, you guys always need accept. So do accept file not found error. All together, no underscore, no space. File not found error. Yeah, right there. Good job. Colon. Print function. No saved model found. Yeah, no saved model found. And yeah, that's it. You can actually for that. So try and accept. So the try and accept block, anything in between the try and accept, it will keep on running until error occurs. And the good thing about try and accept, it wouldn't just exit out of the whole file right away, the execution, but it will catch it. So if you guys do accept file not found there, then it will catch only the file not found there. If you guys have like, I don't know, Stack Overflow or something, then it won't catch it. It'll just exit right away. But if it encounters a file not found there, which is a class, it'll print this no save model found. But yeah, this is typically a useful block. But yeah, you can stop sharing. And that's for Python. And for C++ or C, you guys have try and catch, which is different. And I'm pretty sure JavaScript is also try and catch. I think Python is the only weird one that does accept. And yeah, for Python, whenever you guys do error handling, it'll be exception classes. So you guys can either use pre-made ones like the file not found there, or sometimes you guys can make your own exception classes. I mean, you guys would need to inherit from a specific exception class, but yeah. Anyways, that's the AI brain function. I mean, file. Next file, what should we do? Main.py or let's just make the classes first and then do the main.py last. So let's do Pong underscore game.py next. And Nicholas, can you share your screen? Or Liam? I don't know if you guys are there. You can? Okay. Do you need the live share? Yeah. Do you want the GitHub or this one's the GitHub. Up to you on what you want. And then we can just do two easy functions. But yeah, any questions so far while he loads that up? Okay, accept read and write. Should have access now. Pong game class. So this is basically the game class, like the UI. So we're just gonna build that. So this is gonna be a lot of variables that we want to configure for this class. First, delete that pass, and we'll do self.width, width,
Again,
width, width. Yep,
with
comma, self.height. Yep, equals 400, 300. Yeah. Enter self.visual equals visual. So only the visual variable is passed in when we initialize the class. Enter. Now, if self.visual, colon, we just want to see if it exists. Or actually, it's set to true, so uh, yeah, that's good. Enter. No. Or yeah, you can do equals equals true. And then pygame.init, init, init. Yep, and that's a function, and we don't pass any arguments in it. Yep. Next line, self.screen, sc, yeah, my bad, equals pygame.display dot set mode dot display dot set underscore mode. And that's a function, and we're passing in a tuple of self.width, self.height. Width, comma, self.height, and that's actually a tuple, so you're gonna want to wrap it around circle brackets. Yeah. Closing bracket, and then to the left of the circle, self.width, you want to do a circle bracket. Yeah, yeah, right there. Yeah. And then one more at the end. No. No, no, no. So you see the width, delete the right circle. No, that one's good. That one's good. Yeah, yeah. And then delete the opening one. Yep. Yep, that's good. Enter next line. We're gonna do pygame dot display dot set underscore caption. Caption CAPTION. Yep, and that's a function, and we're passing in a string AI Pong training. Yeah, that's good. Next line, self dot font equals pygame dot font dot capital S sys font YS capital FONT. And that's a class, and we're passing in a string capital A Arial RIAL. No E. Yeah. And then actually next to it, we're gonna want two arguments. The next argument is 18. So it's just the font type and then the font size. So it's gonna be like this. Yep. And then next line, outside of the if statement, some backspace. You're gonna do self dot reset, and that's a function. Yeah. So when we initialize this class, we're just resetting it after setting all our variables. Yeah, that's good. Now let's go to reset. Actually, actually, you can stop sharing. Albert, can you share screen? Oh, I don't think I saw any notifications. You're good, Nicholas. I think it's because you only shared the VS Code, so it doesn't show anything else. So it's fun. And like, uh, you guys don't need to care about this as much as like class and stuff like that. So like notifications, I don't really care about it. So it's fine. And actually, maybe when you guys do go to the washroom, just letting me know is good too. So thank you for Charlie for letting me know last time as well. But yeah, other than that, you guys are free to do whatever. Um, where were we? You have to go to Pong game. Yeah, that one. So we'll do reset. So it's not a lot. We'll just do self.pedal underscore y, self.pedal underscore y equals not 150. We'll do self.height slash slash two. So that's integer division. So one slash is just division, so it allows like floaters. So 5 divided by 2 equals 2.5, whereas integer division, as it says, is an integer division, so 5 divided by 2 would be 2. I'm pretty sure it floors it, unless it seals it. So flooring means rounding it down, sealing means rounding it up. Yeah. Next line, you're do self.ball underscore x equals self.width, integer division by 2. And next line, we'll do, yeah, ball underscore y, ball underscore dx, dy. Random. So for ball underscore y, we'll do random of 50, comma, self dot height minus 50. And we'll do random dot choice. The dx will be minus 5 and 5. Yep. And then the self dot dy will be minus 6, minus 4, comma 4, comma 6. So minus 6, minus 4, so we'll have four values. Minus 6, minus 4, comma 4, comma 6. Okay, next line. Uh, we're not done that other one yet. We're just gonna return the self dot return self dot get state. Yeah. So for you guys that don't know, so ball X and Y, you guys should know it's just the location of the ball. Pedal Y is just the location of the pedal, but dy and dx, do you guys know what that is? Oh, are there like grade 12s here or grade 11? I have like no idea who you guys like what age you guys are, but grade 8. Oh, so most of you guys are middle school or yeah, middle school. Grade 10. Okay. So still like grade 12. Nobody 12. Yeah, Albert, you're right. It is derivatives. I'm not sure how a middle school knows that, but yeah, it's it's basically oh, you're grade 12. Okay, that makes sense. Then wait, Albert, are you gonna study computer science or okay. Are you planning to go to SFU or UBC? U of A? Oh, in Alberta. Okay. Albert Alberta is really cold. The one of my coworkers, they come from Alberta, and apparently it was a snowstorm like 2 weeks ago or something. But yeah. Anyways, dy dx is calculus, so something called derivatives. But for those of you that don't know, it's basically the rate of change. So how fast do we want x to change, or how fast do we want y to change? Dx, as it says, means the rate of change of the x value. Dy is the rate of change of the y value. Basically, we're basically saying since this dy is a random choice between -5 and 5, let's say it randomly chose 5, then we're basically adding this to the x value that it currently is. So that's the rate of change. And we're basically saying we want to set this to be the random dy dx. You can stop sharing. Uh, next we'll do so we did reset. Let's do okay. Adam, can you share your screen? And we'll do a step function.
Mm.
Yeah, Nicholas, you can do it. Thanks for letting me know. Oh, let me accept you. Okay, accepted it. And Albert, I don't know how much you want to prepare beforehand, but I know that I think people struggle a lot with linear algebra when they enter CS, just for your information. And then you start off with like calc, and your first intro class will probably be Python. So that's probably fine. But yeah, Pong game. We'll do step function. So go down to the step function, and we'll do start up there. So do if action equals 0 and self dot pedal underscore y. It was working fine. Why is it doing that? Uh, and and self dot pedal underscore pedal wait self dot pedal underscore y is greater than 0 colon uh yeah, enter self dot pedal underscore y minus equals pedal underscore y minus equals 10. Enter backspace elif action equals 1 and self dot pedal underscore y is less than self dot height minus 60 colon self dot pedal y plus equals 10. Enter backspace self dot ball underscore x plus equals, oh, Nicholas is back, plus equals self dot ball underscore dx. Enter. Now do it for the y. Self dot ball underscore y plus equals self dot ball underscore dy. Oh my. Okay, let me. Maybe I have to like kick the other person. Give me 1 second. How do I kick or remove? Whatever. Let's just continue. Self dot ball underscore y plus equals self dot underscore, I mean, self dot ball underscore dy. Enter reward equals 0, then equals false. Enter, then equals false. Just keep it. Okay. Then equals false. That's a capital. Yep. Enter, enter. You're gonna do if, actually, you can stop sharing. Yours is way too laggy for some reason. Where's my? Whatever. Was Charlie, can you share your screen? And we'll just finish off that function. Step. Yep. If self dot ball underscore y less than or equal to 0, or self dot ball underscore y equals, greater than or equal to self dot height colon self dot ball underscore dy multiply equals, so times equals -1. Enter, backspace. If self dot ball underscore x is greater than or equal to self dot width. So these are the bounds, right? If the ball is greater than the width, then we want to set it back. Just do if to the width and then colon. And then we'll do the if again, self dot pedal y is less than self dot ball y is less than self dot pedal y. Pedal y plus 60. So as long as in between, we're doing self dot ball underscore dx times equals -1.05 and reward equals 10. Next line. Enter, else we're gonna do reward equals -10. Done equals true. Enter, still in the else, yeah. Enter backspace twice. Elif self dot ball underscore x is less than or equal to 0. Just colon. Self dot ball underscore dx times equals -1. Enter backspace, and we're gonna return self dot get underscore state function comma reward comma done. Yeah, that's it. You can stop sharing. And very quickly, for get state, we're just converting the ball and the pedal position into a grid. So it's just a tuple. And we're dividing the x coordinate by 40. So it's just a factor to make the map smaller. and returning these as a coordinate. So we have stuff.ballx integer division by 40. As I said, I think it's floor. Actually, let's see. There's Python integer division round down. Okay, yeah. It rounds down, so it's a floor function. So it basically does divide by 40 and then rounds down, and we're converting it to an integer, which actually we don't even need because integer division is already doing it. But yeah, we're doing these for ball X value, ball Y value, and the paddle Y value. The reason pedal only has one value, the Y value, is because it's stationary on the horizontal and just moving up and down, as you guys saw in the demo, right? And I think we stop right here for in terms of coding for today. Think, yeah. And then let's watch a Fireship video and then close it off with Lick It. Let me share my screen.
Week, Google did something that no other FANG company has had the balls to do. They released a large language model that qualifies as truly free and open source under the Apache 2.0 license.
In the meanwhile, I'll stop the recording and I'll post it to YouTube so that you guys can see it.
That means free as in total freedom, not open-ish,